Hi guys! Okay, so sorry that we couldn't finish the lesson today, and I really want you guys to learn, so I put up a video for you for 1.3. Although it's review, please watch it till the end, and I'll make sure you're ready for 1.1 all the way to 1.3 for Monday's quiz, okay? Remember, even though it doesn't count, Miss Chang will still see your results and kind of have an idea of what kind of student you're going to be for the rest of the year. So if you want that judgment to be on your good side, make sure you study and do all your work until 1.1 through 1.3. If you have any questions, you can watch the video over and over again if you like for more clarifications, or if you have any questions, please come in, okay? Also, one other thing, guys, it's really good to have you guys in my class. I feel like it's only been twice since we've met, but I feel good about this. Okay, I feel like this year's gonna be a good year, and I hope we have that momentum. We keep that momentum going. Okay, so watch the video till the end. Bye. Wait, I'll be back. So this is a 1.3, and as I told you, this is how all the lessons are actually conducted in class. Pretty much everything, okay? So you guys, this is how do you simplify and evaluate algebraic expressions and equations. And I mean, we kind of already know this. So here's some basic vocabulary. So this is part 1, vocabulary. So the following is an equation. Is the following an equation or an expression? Let's see, okay? So you guys, what distinguishes an equation to an equation and an expression? What? Yes, you're right. Equation always has an equal sign, right? Equation always has an equal sign. An expression does not. Expression only has operations, right? Okay? Okay. So you guys, an equation example would be like x plus 2 equals 5. Where an operation would be, or expression would be, x plus 2. And that's an expression. So that means you have, Sam has some number of apples, and you add 2 more apples. Okay? So here you go. So so that's expression and equation. That's a 2 vocabulary for you. How about how many terms are there? What are terms, right? So let's look at an example here. We have negative 5x plus 2w minus 10. How many terms is that? That's 1, 2, and 3. That's 3 terms. So this is a constant, but this is actually still 3 terms. Okay, 3 terms. But how about what is the sum of the coefficients? So if you know the difference between, if you know this definition of coefficients, then you should be able to solve this. What's a coefficient? Coefficient are numbers in front of the variable. Again, like I said, you may know a lot of this. That's why this lesson is pretty much a review lesson. Alright? So if you don't need to watch the video, try doing the homework on your own and see how it goes. Okay? So the coefficient for this expression is negative 5 and 2. And negative 10 is actually the constant because it never changes, right? This is the constant, right? And these are the coefficients. So one underline, okay? So then the sum, it would be negative 5 plus 2, which is negative 3. All right. So I'm sure you're rolling your eyes right now, right? Now, true or false? Negative 5x and 2w are likey terms. Here's another definition word, like terms. And what makes something a like term? Like terms must have the same variable. Are these the same? Not the same. Therefore, not likey terms. So these are not like terms, okay? But you already knew that, right? Maybe if you didn't, it's okay because we're doing this lesson right now, right? All right. Now, if you have to stop the video, make sure you stop the video and try to digest that as much as you can, or you can rewatch it, okay? Make sure you're taking notes as well. So here's part 2. So I like to call this combining likey terms. So it's actually CLT, okay? That's for short. combining likey terms. Alright, so you guys, combine like terms to simplify. So let's first see, are these likey terms? And you say, no, not likey terms. So we can't combine them, so it's just simplified. It's just the answer. You can't simplify, that is simplified. Okay? Simplify and combining likey terms. Let's look at this one. Whoa. Don't be afraid of the fraction, okay? So we have to think, are these likey terms? But there are likey terms, aren't there? This guy and this guy has y squared, but this guy is alone and this guy is alone. Because there's no y's, there's no x squares anywhere. So what can we do? So we can try to combine just these two together, huh? But they still need LCD. So LCD is 12, right? So it's going to be x squared over 5. And we're going to go like this. Okay? And let's actually separate that. So 2y squared over 3 minus 3y squared over 4, right? So we're going to have 12 here, 12 here, 4, 8y squared, 3, 9y squared. It's going to be minus y squared over 12, and then minus y over 4. Notice it's all in standard form, so x squared, y. And that's the answer you should have ended up with this. And if you don't understand it, make sure you ask me in class, okay? Make sure you understand this, and if you don't, make sure you ask me in class, okay? Here's the next. Translating English sentences into math expressions. Again, this is another review lesson, okay? Translating English sentences into math expressions. Next part to continue is translating English sentences into math expressions. So it's sort of like, you know, you have your Sally is 5 years younger than Miss Chang. How would I write that into a mathematical equation or an expression? That's what we're going to work on, okay? Again, this is a review lesson. Okay, so here's some key words though. Let's think about some key words, okay? You remember the word for add? But it's going to be like sum, right? You have sum. What do you say? Product, yeah. Quotient, right? You also have quantity, like a total sum of everything. Less versus less than. You also have greater versus greater than, okay, etc. You may know a lot more, okay? But remember, use real life words to equate it with a mathematical operation. So here's the first example. The quotient of the difference between 8 and a number x and 5. So quotient is a keyword, difference is a keyword. So quotient of the difference between 8 and a number x. So it's 8 minus x, that's the difference between 8 and a number x. The quotient, which signifies the division, and 5, and that's it. It's a mathematical expression, okay? Oh, don't forget another keyword, is. But is implies equal sign, right? But do you see any is here? There is no is. That's why it's an expression. Okay? And here's the next one. The product of 8 and a number x less 2. Again, no is, therefore an expression. The product of 8 and a number x less 2, that means it's got to be 2 less than that. Okay? Let's go next. The product of 8 and a number x is less than 2. Oh, okay, so it's going to be 8. It's not much different than the other one, but it's less than 2. So it's going to be less than. It's an inequality symbol, isn't it? Less than 2. Okay? Let's go on to the next one, last one. 8 less the product of 2 and a number. Less, oh sorry, I forgot to underline all the keywords here, huh guys? So let's go the product of less, okay? And less, product, again product here too. Less than, and this one is just less, right? 8 less, the product of 2 and a number. 2 and a number is this, right? but it's 8 less than that, so it's going to be minus 8. Even though 8 is mentioned first, you know that it goes after. Because if I say Sally is 8 years younger than Miss Chang, I would take Miss Chang's age and subtract 8 from it. Okay? Alright. So make sure you stop the video if you're having trouble understanding this, okay? And here is part 4. Finally, translating English sentences to math expressions. Just thought maybe you were bored, so okay. Alright, so you guys, translating English sentences to math expressions. Here we go. Write an algebraic expression to model the situation. So now you're going to go the other way, okay? I'm going to give you a situation, and you write a mathematical expression for it using variables and, constants, coefficients, whatever you need. So this one says, ticket prices for admission to a museum are $8 for adults. Okay, so you know you have adults, so let's actually write some notes. Adults, and you also have $5 for children. So I'm going to write children here, and you see these are key things, so I'm going to underline that. Also $6 for seniors. There's another set of people, seniors. So I always like to use a variable that's relatable to the actual topic or the actual noun, okay? So it's $8 for every adult that comes, okay? It's children, every child is $5, and every senior citizen is $6. Oh, no, sorry, not C, but senior citizen, so it's S. That expression will tell me, depending on how many members come, that'll tell me how much I'll make or how much the movie theater will make, okay? Now, this is a long one and last one. You're on a bicycle trip. You traveled 52 miles the first day. Since then, your average rate has been 12 miles per hour. That's a rate, right? Right? What algebraic expression models the distance you have traveled so far? So, let's see. So how many miles have you traveled so far? Right now, you've traveled 52 miles already. Okay? But you're traveling after 1 hour. Think about it. After 1 hour, you're going to do 52 miles. After 1 hour, aren't you going to have driven 12 more hours? That's after 1 hour. But how about after 2 hours then? Isn't it 52 plus 12 times 2? Because every hour you're increasing. So if you follow that model, it's going to be 52 plus 12 miles per hour. So H equals number of hours. Again, I'm going kind of fast because I know this is review for you. Okay? And that's your expression. And that concludes our lesson for 1.3. Told you it was easy. Okay? So you guys, the end. Good luck, and I'll see you Monday. Make sure you're ready for the quiz. Okay? Bye, guys.